Hey guys, welcome to another video on ECE 202, and today we will be talking about voltage dividers. This video builds on the concepts we learned in the Ohm's Law video, and I highly suggest that if you haven't seen the Ohm's Law video, you pause this video right now and go watch it. It explains the relationship between current, voltage, and resistance, and how to perform circuit analysis using a simple equation. Alright, for those of you that are here, let's talk about voltage dividers. In the video on Ohm's Law, I said we could use Ohm's Law to describe a voltage divider. But before we do, what is a voltage divider? The resistors in this circuit are in series, meaning that the same current coming from the input source must pass through both of them. This also means that the voltage from this 5-volt source will be split between them. Now, if we have the current and resistance, we could quickly find the voltage drop across resistor 1 using Ohm's Law, and the equation will be V1 is equal to I1 times R1, V1 being the voltage across this resistor, I1 the current running through the resistor, and R1 the resistance of that resistor. But what if we do not have the current? What if we only have this voltage right here? We know that the total voltage must be the sum of the voltage across both resistors. So VT must be equal to V1 plus V2, where V1 and V2 are the voltage across this resistor and this resistor, V1, V2 respectively. And now if we apply the equation for Ohm's Law to this, we can see that Vt is equal to I1 R1 plus I2 R2. Remember that Ohm's Law is just V is equal to I times R, where I is the current running through that resistor, and R is the resistance of that resistor. And now, since we've already established that the current running through the first resistor is the same as the current running through the second resistor, that they both share the same current, we can then say that Vt is equal to I times R1 plus R2. Note that this means in order to find the total resistance of circuit elements in series, you simply add the resistances together. I'm just going to put that as a side note here, that the total resistance is equal to the sum of all the resistances, R1, Rx, and that's just a summation sign. So therefore, if we solve for current over here, we find out that current is equal to the total voltage divided by the total resistance, which in our case is just R1 plus R2. And now, since we have an equation for the current, we can sub that back into our original equation to get the voltage of this resistor over here. So we find that if I sub that back in, the voltage of resistor 1 is just going to be the current of resistor 1, which we've already found out here, times the resistance of that resistor. So subbing that back into our equation, we find that the voltage across resistor 1 is equal to the total voltage divided by the sum of both resistances times the resistance of resistor 1. And now this over here is our equation for a voltage divider specific to just this circuit. If we want to generalize, however, and develop a generic equation for voltage dividers, we can say that the voltage across the resistor in question, resistor I, is going to be the total voltage Vt times the resistance of the resistor in question, resistor I, divided by the total resistance RT, the sum of all the resistances, that is equal to RT. So there you have it, guys. This right here is our generic equation for voltage dividers. Now what this means is that we can find the voltage across any resistor I if we take the total voltage times the resistance of that resistor I divided by the sum of all the resistances. In our circuit, the voltage is the same for each resistor because they both have the same resistance. I'm just going to highlight both resistors to show you that the voltage is indeed the same. 2.5 volts down there in the bottom right and 2.5 volts again. But if I increase the resistance of the first resistor, you can see that the voltage is unevenly split in favor of the first resistor. And I'm just going to prove to you guys that indeed it is unevenly split, 3.013 for resistor 1 and 1.987 for resistor 2. But you may also have observed that the current stays unchanged for both resistors, 1.325 milliamps, 1.325 milliamps. This is because, as we said earlier, they do share the same current. Let's try an example circuit. Someone has made a messy circuit that I don't even want to look at. Luckily, they gave us a voltage drop over the resistor in question, which is this resistor over here. And this is the voltage drop they have given us, which is 90 volts. So for now, we can ignore the rest of the circuit. So one thing we can observe about this circuit is that these four resistors, 1, 2, 3, and 4, are all in series. So as you may have guessed, we are going to use voltage dividers. And if you remember the formula for voltage dividers, we said it was the voltage across the resistor in question, resistor 3, is just equal to the total voltage times the resistance of that resistor divided by the total resistance. So let's go ahead and find the total resistance. Total resistance is just going to be equal to the sum of all resistors, so 1 through to 4. And we figure out that by adding the resistances of all the resistors, that the total resistance is equal to 4k ohms. Now that we have the total resistance, we can plug all our numbers in to the voltage divider equation and find out the voltage across the third resistor. So V3 is just going to be equal to the total voltage, which we've seen here is 90 volts, times the resistance of resistor 3, which is 400 ohms. 400 divided by the total resistance, which is 4000. We find out that the voltage across resistor 3 is equal to 9 volts. Now that we've solved that, let's go back to our circuit and see if indeed the voltage is equal to 9 volts. I'm going to hover over this resistor and it shows that indeed Our calculations were right and the voltage is equal to 9 volts. You guys can try out an exercise by figuring out the voltage across each individual resistor in series. So across this one here, this one, since we've already done that one, it's not needed, and this one. The answers should be on screen for you to compare your results. In our video on current division, we will use a similar approach to derive an equation for resistors in parallel. This, guys, was a simple tutorial on how to derive the equation for voltage dividers and use that same equation to figure out the voltage across resistors in series. Thank you guys so much for watching, and I'll see you in the current dividers video.